Good morning. Today we're going to talk about a apply numerical method in MATLAB. At this chapter or at this point, we're going to have a short discussion about numerical method. So let's proceed to our chapter 1. Our chapter 1 here is mathematical method, mathematical modeling, numerical method, and problem solving. Our objective for this chapter is the primary objective of this chapter is to provide you with a concrete idea of what numerical method are and how they relate to engineering and scientific problem solving. Specific objectives and topic covered are our learning objective number 1 is learning how mathematical method can be formulated on a basic of a scientific principle of simulated and the behavior of a simple physical system. And number 2, understanding how numerical method afford a means to generate solution in a manner that can be implemented on a digital computer. 3 is understanding the different type of conservation laws that lie beneath the models used in the various engineering discipline, and appreciating the difference between steady state and a dynamic solution of those models. And 3, learning about the different type of numerical method we will cover in this book. So that is all our chapter objective. So let's proceed to our slide. 1.1 Simple mathematical method. A simple mathematical method can be broadly defined as the formulation or equation that express the initial feature of the physical system or processes in mathematical terms. So, mathematical model is broadly defined, no? Is broadly defined to express, para ma-express natin yung physical system or process ng mathematical terms. So, in a very general sense, it can be represented as the functional relationship of the form dependent variable, or f is equal to independent variable parameters forcing function. So where independent variable is a characteristic that usually referred the behavior or state of the system, and independent variable is are usually dimensions such as time and space along with the system behavior is being determined. So in this independent variable, no, so we going to um, measure here or determine here the time and the space. Okay, so and the second one is parameter, are reflective of the system properties or composition, and last one is forging function, are external influence acting upon it. Okay, so let's proceed. 1.2 Conservation laws in engineering and science. There are major organizing principles in science and engineering. Among the most important of those are conservation laws. Although they form the basic for a variety of complicated and powerful mathematical method, the great conservation laws of science and engineering are conceptually easy to understand. They are all boiled down to change is equal to increase minus the decrease, as you see to our slide. Okay, so aside from predict change, another way to which conservation laws are applied for cases where change is non-existence. If change is equal to 0, then the equation become, if our change is equal to 0, our equation is increase minus the decrease, or our increase is equal to the decrease. If the change occur, the increase and decrease must be balanced. This case with is which is also given a special name, that steady state calculation. Okay, so Here is a numerical method covered in this book. We're going to discuss this part, the part 1 or A. A is part 2, root and optimization. B or the part 3 is a linear and algebraic equation. And part 4, we have here our part 4 is part 4 curve fitting, and part 5 or D is integration via differentiation. E or part 6 is different equation. So
Okay. Good morning, sir. This is the continuation of our report in part 1, and this is the chapter 2. So, chapter 2, MATLAB Fundamentals. So, let us read the objectives. Number 1, learning how to real and complex numbers are assigned to variables. 2. Learning how vectors and matrices are assigned values using simple assignment, the colon operator, and the linspace and logspace function. 3. Understanding the priority rules of constructing mathematical expression. Uh, 4. Gaining a general understanding of built-in functions and how you can learn more about them with uh, MATLAB helps facilities. 5. Learning how to use vectors to create a simple line plot based on an equation. Next. The MATLAB Environment. MATLAB is a computer program that provides the user with a convenient environment for performing many types of calculation. It provides a very nice tool to implement numerical methods. MATLAB uses the three primary windows. So these are the examples: command window, graphics window, and edit window. Next. We will make use the command and graphics window. Noted, we will use the edit window to create M files. The command window will open with the command prompt being displayed. So this is the command prompt. The calculator and mode of MATLAB operate in a sequential fashion as you type in commands line by line. For each command you get a result. For example, command prompt 56 is minus 16. MATLAB will display the result. So answer is equals to 39. Next. Scalars. The assignment of values to scalar variables is similar to other computer languages. Example, try typing. Command prompt A is equals to 4. Noted how to assign echo prints to confirm what you have done. A is equal to 4. Next. Echo printing is a characteristic of MATLAB. It can be suppressed by terminating the command line with a semicolon. Character. Example, try typing. Command prompt A is equals to 4, A is equals to 6, X is equal to 1. A is equal to 4. MATLAB treats name in a case-sensitive manner. Example, command prompt small letter A and command prompt big letter A. Array, vectors, and matrices. An array is collection of values that are represented by a single variable name. One-dimensional are called vectors, and two-dimensional arrays are called matrices. So these are the example. Example, a row vector can be assigned as follows. So these are the example, and the result is here also. So next, column vectors can be entered in several ways. Now, there are three examples here are represented. There are 1 column, 3 column, and also 3 column. Next, the colon operator. The colon operator is a powerful tool to create and use to separate two numbers. MATLAB generates the number between them using an increment 1. Now, example, command prompt T is equal to 1 and 5. Result T is equal to 1, 2, 3, 4. The linspace and logspace functions. The linspace and logspace functions provide other handy tools to generate vectors of space points. The linspace function generates a row vector of equally spaced points. It has the form linspace x1, x2, and x3. So these are the example we can see here. Next, the logspace function generates a row vector that is logarithmically equal space. It has the form logspace x1, x2, x3. Example, command prompt logspace -1, 2, and 4. Result. So these are the answer: 0.1000, 1. 0, 0, 0, 10 points. Mathematical operations. Operations with scalar quantities are handled in a straightforward manner, similar to other computer languages. The common operators in order of priority are: first, exponentiation, negation, multiplication, division, left division, squared, additional, and subtraction. So these are the examples. A use of built-in function. MATLAB and its toolbox have a rich collection of built-in functions. You can use online help to find out more about them. Example, plug. Log natural logarithm. Result. Log x is the natural logarithm of the element of x. Complex results are produced if x is not positive. See also log 2, log 10, exp, and log m. One of the important properties of MATLAB built-in functions is that they will operate directly on vector and matrix quantities. These are the example we can see. Next, so graphics. MATLAB allows graphs to be created quickly and conveniently. Example, command from plot t over v. So these are the example of the plot.
Good day and welcome again to our next discussion. Programming with MATLAB. This is chapter 3. M-file. The most common way to operate MATLAB is by entering command and at the time in the command window. M-file provide an alternative way of performing operation that greatly expand MATLAB problem solving capabilities. Okay? So two flavor of M file. Number one is a script file. A script file is merely a series of MATLAB commands that are saved on a file. They are useful for retaining a series of commands that you want to execute on the more than one occasion ba? Sige. Our example is example number 1 problem. Develop a script file to compute the velocity of the free falling bungee jumper. Our solution is open the editor with the menu selection, file, new, M file type in the following statement to compute the velocity of the free falling bungee jumper at the specific time. So our constant gravity or G is 9.81 and our mass or M is 68 and time is 12 or amo na ang aton nga velocity, no? So T is our velocity and G is our gravity. Our gravity here is always constant 9.81 meter per second square. And then ang M, so ang ating M is that is mass. So 68 kilogram and time or our time is 12 and CD is 0.25. So result is V or velocity is equal to 5.6175. Okay, so let's proceed to next slide. Our next slide here is function file. Our function file are M file that start with the word function. In the construct the script file, they can accept into agreement and return outputs. Hence they are analogous to user defined function in a programming language such as Fortran, Visual Basic, or C. The syntax for the function file can be represented generally as a function outvar is equals to function name, open parenthesis, arglist, close parenthesis, %help comment, and the statement outvar is equals to the value. Okay, so where outvar is equals the name of the output variable, func name, the function of name, arglist is equal to the function argument list, help comments text the provide the user with information regarding the function statement, a MATLAB statement that compute the value that is assigned to outvar. Example, problem statement compute the velocity of the free falling bungee jumper that but now we will use function file for the task solution. Function v is equals to free fall vel open parenthesis t m and cd times mo lang yon, and then free fall level bungee velocity which we got other drugs, percent v is equals to free fall vel t times m times cd compute the free fall velocity of an object with a second order drag. Okay, going back, subfunction can call other function, although such function can exist as separate M file. They most may also be contained in a single M file. Um, our next is input and output. Information is passed into the function via the argument list and the output via function name. Two other function divide ways to enter the display information direct using the command window. So, the input function. This function allow you to prompt the user for value directly from the command window. So its syntax is n input times the prompt string. So example, m is equals to input times the mass. When the line is executed, the user is prompt with the message mass is kilogram. If the user enters a value, it would then be assigned to the variable m. The input function can also return use input as the string. To do this, an s is appended to the function argument list. For example, name input, enter your name, and s. The display function, this function provide a hardly way to display a value. Its syntax is display times the value, or where value is equals the value would like to display. Okay, so table 3, we have here the table commonly used for control codes employed with the fprint 3.2.1 create and accessing file. MATLAB has a capability to both read and write the data file. The simplest approach involves a special type of binary file called a mat file, which expressly designed for the implementation with MATLAB function. Such file are created and assist with a save and load command. The save command can be used to generate a mat file holding either in in an entire workspace or the few selected variable. A simple representation of its syntax is save file name, var1, var2, and var_n, and so on and so forth. With re-interview the variable var1 through var_n and the file name mat. Next, our next is structured programming. The simplest of all M file perform instructions sequentially. That is, the program statement are executed line by the starting at the top of the function and moving down to the end. The two classification of structured programming. So next one is decision. The first one is decision. The if structure. The structure allow you to execute a set of statement if a logical condition is true. Is generally syntax is if condition statements and where condition is an logical expression that is either true or false. So 3 is loops. Loops perform operation repetitively. There are two types of loops depending on how the repetition are are terminated of for loops and after the specified number of repetition, a while loop and a basic of a logical condition. The white structure. A white loop repeat as long as a logical condition is true. Its general syntax is while condition statement and example x is equals to 8 while x is greater than 8 x is equals to x negative 3 minus 3 display x and result x 8 5 2 and negative 1. And then nesting and indentation. Nesting refers to the placing structure within other structure. Problem statement: the root of the quadratic equation f of x is equals to 8x squared plus bx plus c can be determined with the quadratic formula x is equals to negative b positive and negative square root of b squared minus a 4ac all over 2a. Okay? So, 3.5 passing function to m file. Anonymous function. Anonymous function allow you to create a simple function without creating an file. They can define within the command window with the following syntax. Okay? So, functions. Functions are functions that operate on other function which are passed to it as an input argument. The function that is passed to the function is referred to as a pass function. A simple example is the built-in a function f-plot with plot to graph of function. So proceed. This is the graph of this is the graph of our function and functions. So the graph of that is here. Okay? So ito yung graph natin. Hindi proceed tayo. Okay, that is the end of our chapter 3 and now we going to proceed in chapter 4.
Hello sir, good morning and welcome back. Now we are going to proceed in chapter 4. Roundoff error and truncation error. Our objectives are understanding the distinction between accuracy and precision, learning how to quantity error, learning how error estimates can be used to decide when to terminate an iterative calculation, understanding how round-off errors occur because digital computers have a limited ability to represent number, and last, understanding why floating point numbers have limit on their range and precision. Next. Errors. Accuracy and precision. Accuracy refers to how closely a computed or measured value agrees with their true value. Precision refers to how closely individual computed or measured values agree with such other. An example from marksmanship illustrating the concept of accuracy and precision. Letter A. Inaccurate and imprecise. Now you can see here the example. Letter B. Accurate and imprecise. C. Inaccurate and precise. And D. Accurate and precise. As you can see the example over here in our PowerPoint. Next. Error definitions. Numerical errors arise from the use of approximations to represent exact mathematical operations and quantities. For such errors, the relationship between the exact or true result and the approximation can be formulated as true value is equal to approximation plus error. The numerical error is equal to discrepancy between the truth and approximation. E sub 1 is equal to true value minus approximation. Roundoff errors. Roundoff error created due to approximate representation of numbers. Roundoff errors arise because digital computers cannot represent some quantities exactly. There are two major facets of roundoff. Roundoff errors involved in numerical calculation. Number 1. Digital computers have size and precision limits on their ability to represent number. 2. Certain numerical manipulation are highly sensitive to roundoff errors. This can result from both mathematical consideration as well as from the way in which computers perform arithmetic operations. Truncation error. Truncation errors are those that result from using an approximate in a place an exact mathematical procedure. For example, we approximate the derivative of velocity of a bungee jumper by a finite difference equation of the form. dv is dv over dt approximate equal to delta v over delta t equal v quantity of ti plus 1 minus v quantity ti over t1 ti plus 1 minus ti. Next. Total numerical error. The total numerical error is the summation of the truncation and roundoff errors. In general, the only way to minimize roundoff errors is to increase the number of significant figure of the computer. Further, we have noted that roundoff error may increase due to subtractive cancellation or due to an increase in number of computations in an analysis. Blunders, model errors, and data uncertainty. Blunders can occur at any stage of the mathematical modeling process and can contribute to all the other components of error. Blunders are usually disregarded in discussions of numerical methods. Model errors. Model errors relate the bias that can be ascribed to incomplete mathematical models. Data uncertainty. Errors sometimes enter into an analysis because of uncertainty in the physical data on which a model is based. That's all, and thank you.